Welcome back, class. Last week we had an introduction to the elimination method for solving systems of equations. And today we're going to go in a little bit deeper. We're going to look at some problems where it looks like the elimination method might not work, and we're going to work on changing the equation so that the elimination method does work for solving that system. So one term that you need to know before we get started today is scalar multiplication. Okay, and scalar multiplication is when you multiply one equation. You can multiply more than one equation, but for now we'll just multiply one equation by a number in order to change the coefficients of that equation. Okay, so that's scalar multiplication. It's usually making a small equation and just making it bigger. Okay, so we'll practice some scalar multiplication here in just a little bit. Let me remind you about the steps that we use during the elimination method. Remember that the elimination method works best when your two equations are in the standard form. Okay, because that kind of takes care of step number one. Then step number one is make sure that your equations are aligned, right? We want our x's on top of our x's, our y's on top of our y's, and our constants on top of our constants. Okay, so we want to make sure that our equations are aligned, and if they're both in standard form, then it's pretty easy. They're already aligned for us. Step number two is we're going to find a number that you can multiply one equation by in order to get opposite coefficients. Okay, and I'll show you an example of this here in just a little bit, but we need to find a number that we can multiply one of these equations by so that our coefficients will cancel each other out. Okay, and then step number three is to use scalar multiplication to change the equation. Step number four is to add the columns and solve the resulting equation. Okay, so we've already done that last week. We worked on that. And then step number five is to substitute your answer into one of the original equations and solve for the other variable. All right, so now that we've got the steps down, let's look at a couple of examples and how we can use scalar multiplication to help us solve systems using elimination. All right, in this first example, this is a perfect first example. It looks like when we're looking at it, first of all, both of them are in standard form. Okay, both equations are in standard form. However, my x's aren't going to cancel out my x's, and my y's aren't going to cancel out my y's. So that's a problem, and it looks like we can't use elimination to solve this problem. However, if we use scalar multiplication, we can make it work. If we look at this top equation, if that was a 4y instead of a 2y, then my 4y could cancel out my negative 4y, okay, and that would work. So what we need to do is figure out how can we make this 2y into a 4y. And what we can do is we could multiply it by 2. However, we can't just multiply one portion of an equation by 2. We need to use scalar multiplication. We need to make this whole equation bigger so that I can get this to 4y. Okay, so what I need to do is I need to take this whole first equation and multiply it times 2. Okay, that means I need to multiply this 20 by 2, I need to multiply the 2y, and I need to multiply this 6x. I need to multiply all of those by 2. So let's go ahead and try it. 2 times 6x is 12x. 2 times 2y is 4y. And 2 times 20 is 40. Okay, so basically we can get rid of this first equation. We just used scalar multiplication and rewrote it down below here. Okay, so now I can add these two equations together. Okay, and 3x plus 12x is 15x. Negative 4y plus 4y cancels out. And 20 plus 40 equals 60. I solve for one of the variables, divide both sides by 15, and I get x equals 4. All right, so now we know one of the variables. We need to plug in this variable. We need to substitute it into one of these original equations and find out what y equals. Doesn't matter which one you pick. I would pick the one that looks easiest to you. For me, in this example, I'm going to choose the second equation. Okay, so I'm going to rewrite this second equation, except instead of x, I'm going to write 4. So I've got 3 times 4 minus 4y equals 20. I just use some algebra now. 3 times 4 is 12. Then I subtract 12 from both sides. I get negative 4y equals 8. Then I divide both sides by negative 4. And I get y equals negative 2. I know my x is 4, and I know my y is negative 2. And this is the solution to this system. Okay? Let's try one more example. Here's another great example. Both of these equations are written in standard form, so immediately my brain goes, ooh, elimination, I like that. Okay, but then as I look at it, I know my 6x and my minus x, those aren't going to cancel out. My negative 6y and my negative 3y, those aren't going to cancel out. So I'm stuck, and I need to figure out a way to get one of these to cancel out. Okay, so I need to use some scalar multiplication, I know that. If I look at my y's here, it looks like I could probably get those to cancel out. Okay? And so the first thought that pops into my brain is, oh, I should multiply this equation by 2 because 3 times 2 is 6. But if I just multiply by 2, negative 3 times 2 is negative 6. And I'm going to have negative 6y minus 6y, which is going to leave me negative 12y. Okay, so I can't just multiply by 2. I really need to multiply by negative 2. Because if I multiply by negative 2, negative 3y times negative 2 will be positive 6y. And that will cancel out my negative 6y on top. Does that make sense? Let's give it a go. We're going to multiply this bottom equation by negative 2. Okay, and remember, if I multiply anything by negative 2, I need to multiply everything by negative 2. Just like in the summer when you go to the freezer and you want a popsicle, if you're getting a popsicle, then you're going to have to get a popsicle for your little brother. You're going to have to get a popsicle for your little sister. Everyone wants a popsicle. Same thing when I use my scalar multiplication. If I'm multiplying one thing by negative 2, everything wants to be multiplied by negative 2. Okay, so I can go ahead and try it now. Negative 2 times negative, remember we can always put a 1 right here if we wanted to, if that helps us out. Negative 2 times negative 1 is 2x. Negative 2 times negative 3, we talked about that, that's plus 6y. And then negative 2 times 9 is negative 18. Again, I can just kind of get rid of this middle equation now because I just rewrote it down here. Okay, that makes sense? Then 6x plus 2x is 8x. Negative 6y plus 6y cancels out. And then negative 6 minus 18 is negative 24. Now I can divide everything by 8. And I get x equals negative 3. Now I know my x, so I need to substitute it into one of these equations to find my y. Doesn't matter which one you do. For this one, I'm going to use this top equation. Okay? You can choose the bottom one if you'd like. I'm going to choose this, except instead of x, I'm going to put negative 3. 6 times negative 3 minus 6y equals negative 6. I just used some algebra now. 6 times negative 3 is negative 18. Then I need to add 18 to both sides to get rid of this negative 18. Negative 6 plus 18 is 12. And then I just divide by negative 6. And 12 divided by negative 6 is negative 2. So I know my y, I know my x. If I write it as an ordered pair now, my x is negative 3, my y is negative 2, my solution is negative 3, comma negative 2. Okay? And we solved that system using scalar multiplication to help us with our elimination. One last example, then I'll cut you loose on your own. All right. Another really good example here. Man, I picked some good ones today. Check out this one. Again, they're both in standard form. So my x's are on top of my x's, my y's are on top of my y's, my constants are on top of my constants. When you look at this one, man, it almost looks like those y's are going to cancel each other out. I've got 3 on top of 3. But they're both positive. So if I were to add these together, 3 plus 3 would be 6y. Okay, and I don't want it to be 6y. I want it to be 0. So what I'm going to need to do is I'm going to need to do some scalar multiplication to change these so that they cancel each other out. Okay, and I'm sure most of you have figured it out by now, but I need to multiply one of these equations by negative 1. Okay, because then that would make this a negative 3 and this a positive 3, and they'd cancel each other out. So I'm going to go ahead and use this top equation, although in this case you could multiply either equation by negative 1. Okay, I'm going to use the top one. Okay, so I use my scalar multiplication. I'm going to multiply everything by negative 1. And negative 1 times 2 is negative 2x. Negative 1 times 3y is negative 3y. And negative 1 times 1 is negative 1. I've used my scalar multiplication. Now it's time to add the columns. I'm done with this top equation. Sometimes it helps me visually if I just cross it out so it's out of my mind, out of the problem. Okay? I just add these columns. 3x minus 2x is 1x. 3y minus 3y cancels out. And then 6 minus 1 is 5. So x equals 5. So far, so good. I can plug that 5 into either one of those equations and figure out what my y would be. You could pick whichever one you like. I'm going to choose the top one. Okay? So I'm going to rewrite it, except instead of x, I'm going to substitute a 5. Two times 5 gives me 10. Okay, then I need to get rid of this 10 so I can get y all by itself. So the way that I get rid of 10 is I subtract 10. If I subtract 10 to one side, I need to subtract 10 from the other side. And 1 minus 10 is negative 9. Now I know that 3 times y is negative 9. So to figure out what y is, I just divide by 3. And I get y equals negative 3. So my solution then is 5, comma, negative 3. Okay? That is scalar multiplication. Okay, we're going to start off with some pretty easy ones in the examples that I have left for you. Try those 3 examples, see how you do. You can check your answers tomorrow in class. And I hope it comes easy for you. If you have any questions, make sure that you write them down in your notes so that you can ask them in class tomorrow. All right, thanks a lot for watching.